We're going to talk about Lewis structures and how to draw them. A Lewis structure is an electron dot structure for a molecule that shows the bonding between atoms in a molecule and the lone pairs of electrons. You want to start off by counting the total valence electrons of the molecule. You want to remember that I can find the valence electrons of any main group element by looking up its group number on the periodic table. Then I want to draw the skeletal diagram with single bonds. You have to decide which atom goes in the center and which atoms are going to be the terminal atoms. Then you're going to place the remaining electrons as lone pairs. You want to start placing those electrons on the terminal atoms, and if you need more space, then you can go ahead and place them on the central atom. If each atom does not have an octet, then you're going to have to change the lone pairs to bonding pairs. Remember, the octet rule is the tendency of main group atoms to form enough bonds to obtain 8 valence electrons. Now, there are exceptions to the octet rule. The most common one is hydrogen. Hydrogen will only have 2 electrons around it in a Lewis structure, and that means it will only have 1 bond to it. So hydrogen will never be in the center of the molecule. Step 5, you want to show all your resonance structures when possible. Remember, resonance is when 2 or more equally correct dot representation of the same molecule is possible. You want to show your resonance structures with double arrowheads. Let's take a look at the first example. Let's draw the Lewis structure for CH3Cl. The first thing you want to do is count the valence electrons. There's only 1 chlorine, and chlorine is in group 7, so 1 times 7 valence electrons. There are 3 hydrogens, and hydrogen is in group 1, so 3 times 1 is 3 valence electrons. There's 1 carbon. Carbon is in group 4, so 1 times 4 is 4. I'm going to add up these numbers, and I have 14 valence electrons, which means I have to arrange 14 electrons in this Lewis structure. Step 2, I have to draw the skeletal diagram with single bonds. Now, hydrogen does not obey the octet rule. It will never have more than 1 bond on it, so hydrogen can never be in the center of the molecule. Between carbon and chlorine, I pick this atom that is the least electronegative. So the atom or the element that's further away from fluorine is going to be my center atom. So carbon is further away than chlorine. So carbon is my center, and then I'm going to draw single bonds with the terminal atoms. Now I want to place my remaining electrons as lone pairs. I have a total of 14 electrons, and I've used up 2, 4, 6, 8. So I'm going to say 14 minus 8. That means I have 6 electrons remaining. So I'm going to go ahead and place 6 electrons on the terminal atoms, and if I need more space, I go into the central atom. I will never place my remaining electrons on hydrogen because it does not obey the octet rule. So I'm going to go ahead and do it on chlorine. 2, 4, 6. Let's see if I've used up all 14 electrons. 2, 4, 6, 8, 10, 12, 14. So I've used up all of my 14 electrons. Let's see if my atoms are obeying the octet rule. Hydrogen does not obey the octet rule. Carbon, 2, 4, 6, 8. It's obeying the octet rule. Let's check out chlorine. 2, 4, 6, 8. Chlorine is obeying the octet rule. So my final Lewis structure is single bond carbon with hydrogen and single bond carbon with chlorine. And I want to make sure I show all of my lone pairs. I also want to take a look at this structure and make sure that I've shown resonance structures if possible. This Lewis structure does not have resonance structures, so this is my final answer. Let's take a look at another example. Let's draw the Lewis structure for HCN. The first thing I want to do is count the valence electrons. There's only one nitrogen, so 1 times 5 is 5 valence electrons. Carbon, there's only one carbon. 1 times 4 is 4. And only one hydrogen. 1 times 1 is 1. I'm going to add up these numbers and I'm going to get 10 valence electrons. Now I want to decide which one is my center atom. Hydrogen can never be in the center, so it's going to be between carbon and nitrogen. Carbon is further away from fluorine, so carbon is going to be in my center. I'm going to draw a skeletal diagram with single bonds. Now I have to count my remaining electrons. I used up 10. I have 10 total, and I've used up 4. So 10 minus 4 is 6 electrons. So I have to place 6 remaining electrons. I'm going to start off on my terminal atoms. I cannot place it on hydrogen because hydrogen does not obey the octet rule, so I'm going to go ahead with nitrogen. 2, 4, 6. Let's see if I have 10 electrons. 2, 4, 6, 8, 10. I do have 10 valence electrons, and let's see if I'm obeying the octet rule. Hydrogen does not obey the octet rule, so it's fine. Nitrogen, 2, 4, 6, 8. It is obeying the octet rule. And let's take a look at carbon. 2, 4. Oh, carbon is not obeying the octet rule. So I have to do what step 4 tells us. I have to change the lone pairs to bonding pairs. And I think it's a good idea if you start off with one pair at a time. So let's take a look at nitrogen. Nitrogen is the atom that has the lone pairs. And I'm going to go ahead and move these lone pairs and make them into bonding pairs. So it would look something like this. Let's see if this is going to work out. My hydrogen does not obey the octet rule. Nitrogen has 2, 4, 6, 8 electrons around it, which is good. Carbon has 2, 4, 6. It's getting better, but it still did not obey the octet rule. So I'm going to take another pair and make them into bonding pairs. So now my new structure would look something like this. Okay, let's see if this is going to work out. I need to show all 10 electrons. 2, 4, 6, 8, 10. So I have all 10 valence electrons. I need to make sure that my octet is being obeyed. Carbon, 2, 4, 6, 8, which is good. Let's see if nitrogen is obeying the octet rule. 2, 4, 6, 8. Nitrogen is obeying the octet rule. My final answer is hydrogen bonded to carbon, carbon triple bonded to nitrogen, and I show the lone pairs on nitrogen. This structure does not have resonance, so this is what my final answer is. Let's take a look at another example. Let's draw the structure for CO2. First thing I want to do is take count of my valence electrons. I have 2 oxygens, so 2 times 6 is 12. I have 1 carbon. Carbon is in group 4, so 1 times 4 is 4. I have a total of 16 electrons. Okay, now between my carbon and my oxygen, I'm going to choose carbon to be my center atom because carbon is further away than oxygen from fluorine. So carbon goes in the middle, and I'm going to have oxygen on either side. I have 16 electrons. I've used up 2 plus 2 is 4. So I've used up 4 electrons. So I need to place remaining 12 electrons on this molecule. I always start off with my terminal atoms and then go into the center. So 2, 4, 6, 8, 10, 12. Let's see if I'm obeying the octet rule. Oxygen has 2, 4, 6, 8, which is good. The second oxygen, 2, 4, 6, 8, which is good. And carbon, 2, 4. Okay, so carbon is not obeying the octet rule, so I'm going to take lone pairs and change them into bonding pairs. And I'm going to do this one at a time. So I'm going to take this lone pair and make them into a bonding pair. All right, and I'm going to see that this oxygen is still happy, 2, 4, 6, 8. It's obeying the octet rule. The second oxygen, 2, 4, 6, 8, still obeying the octet rule. Carbon, 2, 4, 6. It's getting better, but not there. So we're going to take the lone pair from the second oxygen and make it into a bonding pair. So let's see if that is going to obey. So octet rule, 2, 4, 6, 8. Oxygen is obeying. 2, 4, 6, 8. Oxygen. So both oxygens are obeying the octet rule. Let's see carbon, 2, 4, 6, 8. So that's obeying the octet rule. So my Lewis structure is going to be double bonded carbon and oxygen on both sides. So I know I have all 16 electrons. I know that I've obeyed the octet rule. Now I have to see if there's any resonance structures. Let's take a look at our scrap work. Is there a way that I could have changed my lone pairs to bonding pairs differently than what I did on my scrap work? Well, let's take a look at this. I decided to go ahead and move this lone pair and make them into bonding pair. My carbon still wasn't happy. So what if I went ahead and changed this lone pair and made them into another bonding pair? I would have gotten something like this. And let's see if this would have been okay. I need to show that I have 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. So that's all good. And let's check my octet rule. 2, 4, 6, 8. Oxygen is happy. 2, 4, 6, 8. That oxygen is happy. Let's check out carbon. 2, 4, 6, 8. So this is an acceptable Lewis structure. I've kept the atoms in the same order. Everything is obeying the octet rule. I show 16 valence electrons in both structures. So this is just another arrangement of my Lewis structure. This is called resonance. For you to show resonance, you have to have a double arrowhead. And this will let the reader know that these are two acceptable Lewis structures of CO2. I have to go back to my scrap work and examine this again. Is there another resonance structure possible? Well, I could do the same thing and change up these electrons. I could make those into bonding pairs versus the other oxygen. So then I would have something like this. Once you examine this structure, you're going to find out that there are 16 valence electrons. All of the octet is being obeyed. So this is another acceptable arrangement of a structure for CO2. So I can go ahead and put a double arrowhead. So I have 3 resonance structures for CO2, and you would have to show all of the answers. Good luck and keep practicing.